Hi, my name's Peter Marshall. Welcome to this talk entitled Employ Approximation. These tips and tricks talks have been created to share our experience here at Imply with those of you who are just starting out with Druid. If you've got any questions, don't forget, register on Druid Forum and we'll meet you there. First, let's talk about why you need to think about approximation. And then we'll move on to introduce some of the approximation features in Druid. And finally, I'll talk about how to engage with your end users about approximation, because even the mention of it could be quite scary at first. So, why do they exist? Gian Molino said this: approximations improve scalability, storage, and memory use at the cost of some error. He says that approximation is all part and parcel of the Druid gig. If you use Druid, knowing about approximations is extremely important. Let's take a moment to look at how Druid manages to be so good at sub-second queries on vast amounts of data. At the bottom, you have multiple data servers, historicals and middle manager peons. Each one is reacting to the tasks sent to it by the broker. They select data from segments, scan them, and send their intermediate results up to the broker. The broker merges them, finalizes the results, and passes them back to you. Approximation technique reduces the data footprint. There's less data to transfer around inside processes, and the data being returned to the broker. It reduces the speed cost of, for example, merge operations. There's less data to process, leading to faster scan times of individual segments and of other analytical operations. There's less data in the segments themselves in deep storage, local disk and memory, reducing the monetary cost of doing analytics on extremely large data sets. The data processes that you see here at the bottom of the diagram are the most scalable part of Druid. By using approximation, you make the data servers do as much of the work as you possibly can. So now you know really that approximation is about both storage and computational efficiency. So how can you leverage approximation in Druid? There are 4 techniques: top N, hyperloglog, theta, and quantiles. Top N refers to a special query execution method in the scatter-gathered method in Druid. It optimizes the way that queries which give you heavy hitters execute. For queries that fit a specific pattern, when you're looking for the top 10 countries, for example, or top 50 customers and so on, Druid reduces the amount of data passed up for merging in the layers above. Right down here in each data process, which does ordering and limiting very early. Then there are sketches. Sketches are a class of algorithms that solve a range of problems with high cardinality data. The most popular sketches for distinct count are hyperloglog and theta sketches. At the cost of storage and speed, theta gives you some extra functionality to do union, intersections and differences on your data. And while there are actually 4 different ways to analyze distribution in Druid, the best one to use is the quantiles sketch from the Apache Datasketches project's own library. At Imply, we found sketches are an exceptionally important design consideration so that you can meet that promise of sub-second, massive scale analytics in a Druid-powered application of all kinds. But why? Well, way back in 2013, the team working on Druid had a high cardinality data problem. To store 10 to the 9 elements was going to be really expensive, not just to store, but to try and do analytics on. You may think it's infeasible for you to process this data with any degree of reliability, speed or accuracy, like hundreds of thousands of visitor identifiers, millions of IP addresses, billions of unique ad impressions, like Yahoo did. They wanted to count unique user IDs, but they didn't want to spend much more money. Sketches dramatically reduce the volume and processing cost of high cardinality data problems. And with sketches, it's not just about volume, it's also about extreme levels of query performance. Despite losing a degree of resolution, you can still get results with a predictable level of accuracy. Sketches are a class of approximate, limited size, mergeable representations of input data. When you create and use sketches, the results are approximate. This does not mean unreliable. It means that the error rate of the results is predictable. In fact, there are published error tables for each type of sketch. They're of a limited size and, interestingly, no matter the size of the incoming data. That 10 to the 9 set of values that the Druid team was trying to analyse could be represented as just 2 kilobytes by using a sketch. And finally, they are mergeable. That means sketches can be passed around and then merged instead of millions of individual values. This is sketching in Druid used at query time. Here you brought the data in as you always have, but after the data in segments is opened, each data process is transferring much less data up to the broker process. But you can make this even more efficient. You can actually put the sketches inside the data itself. One way is to generate them using rollup, and that's exactly what Yahoo did. In this example here, notice that the user ID has been sketched at ingestion time. Not only that, but here, because they don't need to filter or sort by the user ID, the original column has gone altogether. At query time, they address this column using a function built for exactly this kind of sketch. Approximate count distinct is used with hyperlog, log and theta. Count distinct, union, intersect and difference with theta sketches, and histograms and ranks with quantile sketches. The data that results is now a factor smaller. Now that's not just good for deep storage costs and for data distribution work and for your server sizes, it's awesome for scan times. And the scan times not just of the queries related to this column, but of all queries on this table. The sketches that I use and rely on, the ones that you'll see in the docs, are part of an Apache project, the Apache Datasketches project. You can read more about them in high detail and contribute to the project yourself at datasketches.apache.org. Next time you run into a challenging counting problem on big data, look into approximate counting as a way to solve those challenges and provide a better experience for your end users. Approximation is a pivotal technique to apply in Druid to give you sub-second query responses that your Druid-powered application demands. But what might your end users think of all this? Well, here's some things that I've heard at Imply, and you're very likely to have heard this yourself. You might even be thinking it right now. My users won't accept approximate results. I can't trust approximate results. My current database can deliver exact results. Why can't Druid? I need exact results for reports, or I need access to the raw data. If people say they simply won't accept approximate results, there's no getting around it. There is a trade-off with sketches. You get scalability and capacity, and users get speed, but they lose an amount of accuracy. But talk to your users. You might find that because the UI you're going to give them is exceptionally fast and has more visible data, you will win the fight over absolutely exact, perfect figures. At Imply, we find that Pivot's use of approximation is key to giving people that visual, exploratory interface that helps them explain what's going on and to be able to dig around in the data, looking at trends and doing comparisons over time periods. What if they say they just can't trust them? For sketches, while results may not be 100% accurate, they really are very close to it. And what's more, provably and predictably so. seek out the published error tables that are especially important for discussions in bringing people on side. And with the top N approach, it's really clear in the documentation where they work well. So with top-heavy distributions in your data and additive measures, and where they don't. Uniform distributions, ratios with small denominators, for example. And what about this conversation about Druid versus some other database? Well, approximations are industry best practice for handling these kinds of problems on high cardinality data at the volumes that you will deal with Druid. It's how many Druid-powered organisations in the community get a price-performance balance that's right for the kind of UIs that they build on top of Druid. Now, there are some people who definitely, unquestionably need accurate results. Your financial return cannot be approximate, and that's perfectly okay. One option you might have is to set up the data and your query to run without approximation turned on. You might consider running some queries using specific context parameters where approximation is then disabled. And you could isolate that work onto a specific cluster tier, or you could use query laning so those kinds of difficult, complex queries don't block interactive queries. But that doesn't work for everything. Druid is about speed, and approximation is a key to getting that at a cost point that keeps you successful. When you can't get 100% accurate results to run at Druid speed, perhaps some database running alongside Druid, one that isn't about interactivity, is going to be the thing that helps you solve the problem. Now, what about raw data? This may come up because people want to filter results using the raw values, for example, like that user ID. Not just because they want to do a CSV export and then crash Excel for a laugh. There are two options for you. You can opt to use those sketching SQL functions only at query time, so don't generate them at rollup or ingest them at ingestion time. And there you'll be accepting that the data you store will be bigger and that Druid will have more work to do, but you will at least get some speed benefit. Or you could create a second sketched table. That sketch table will be blisteringly fast and it will probably end up being your end user's first port of call. But you'll still have the raw data in another table that everyone accepts will be slightly slower. So there we have it, approximations in Druid, a very clean and lean top N query path, and solutions for count distinct, set operations and quantiles by using the Apache Datasketches library. Approximation is a really important technique, not just to make your queries really fast and make a real difference to your users, but also to keep a control of your infrastructure and storage costs as you scale this database up over the years to come. If you want to hear real-life stories about using Datasketches, go into Druid Forum and in the search bar use the term Datasketches. There are tons of videos and articles from community members. If you've got any questions about what you've seen today, register on Druid Forum and raise a question. Say hello to us, we'll say hello to you. Visit learn.imply.io for Druid-related courses. And with me, please say thank you to the developers behind the Apache Druid releases with a star on the Apache Druid GitHub repo. Thank you.